I'm Thomas Sanguinetti with Siemens PLM software, and today I'm going to show you how EMs will be able to estimate emissions, fuel consumptions for real driving cycles using LMS ImagineLab Amesim 15. So in order to do that, we have two possible scenarios. First, to use recorded data from GPS logs, or use maps, OpenStreetMaps, to configure yourself your own waypoints for your car. So to beginning, we'll open some standard demo provided within Amesim. So first, go to your Help menu, then get LMS Amesim demos. Then you go to your library tree, Drive library, and select the gasoline vehicle manual gearbox real cycles. Press the Copy and Open button, and your demo will open in Amesim. From here, we start with the first option, where we will use GPS logs. For my example, I just looked over the internet for some GPS tracks recording waypoints in the Death Valley. So I'll open my folders, look for my Death Valley data file, and you can see here I found some GPX file where all the different coordinates were stored. You can have the same information using your own GPS. First step with Amesim will be to create the road from those GPS tracks. So first we'll use the Amtrack tool provided by the Vehicle Dynamics library. So click on the Amtrack link to open the apps. First we will select the GPS file. So I go directly into my folder, select the GPX file. Then I will create some folder to store all the different visualization and file generated by the tool. Press Generate, and the tool will work by itself. It takes only a few sets of seconds to compute the road. When it's done, now the second step will be to define the trajectory from the vehicle and generate some speed profile which will be used during the simulation. For that, I will launch an additional tool in Python. So you need to click on the blue label on top of your toolbar. It will launch the trajectory import tool. Go to the second tab, then click on the GPS log or track file. From there, we go again in our Death Valley file and select way1.data. This is the file generated by the previous tool, which will be used in our simulation. You can see that it has found one track with a total length of 227 kilometers. Then we go to the third tab, where our GPS file was analyzed and shown on this interface. Okay, so now I will compute the velocity profile. We only need a set of few parameters. First, the maximum allowed driving speed we will use for a car. Then the maximum acceleration our car can go in curves, its mass, maximum power, and top speed. From that, you can see here we have the speed profile as a function of our distance for the entire GPS file. If we zoom in, we can see, for instance here, that we almost always at our top allowed speed, and then for some curves some down acceleration. From here we'll save this file. So click on the Save Data File Overview Plot window, and in the same folder we will save the speed profile. and just type in some name, Days Valley, 7 kilometers. Once this step is done, we have a few adjustments to make for the speed profile. We'll use the table editor within Amesim to open the file and edit some few values. So I will load the previous file. One of the conditions is that we must start at a new vehicle speed and also finish at a new vehicle speed. So first value, as you can see, it had an initial value, so we just type in 0. And we will do the same for the last point. You can save the file. Then also an interesting point for real driving emissions is that we need to add some stops, traffic signs, stop signs. So we will choose some points here, for instance, and at this moment we will enter a new vehicle speed to simulate a vehicle stop. So it's about 182 kilometers. So I'll change the value around here. As you can see, a stop has been added to the file. We'll then save and close the table editor. Now that we have created our own file or cycle, we will need to enter some parameters to simulate our vehicle. So first, I will generate some engine maps. In case you don't have any data, there is an extra tool which will allow with macro parameters to create those maps. Click on your IFP engine drive model and launch the first apps. As you can see, in 6 steps we'll be able to create our own engine. So in my case, I used an inline engine, regular car, not turbocharged, so simple dynamics, 4-cylinder, 1.4 liters. The only parameter requested here is the stroke. Then we'll define if it's a gasoline or diesel engines. In our case, it's gasoline engines. We'll also need to define some maximum torque and maximum power at their different engine speed. So for that, I will look into my data. I saved a few set of informations. Here. So it's as I said, 1.4 liters, and we have a maximum power of 110 kilowatts. So type in here. We know that it's the case between 5,000 and 6,000 RPMs. So we don't have the value accordingly. We say 5,000. And for the maximum power, we will maximum torque. We will use these values, so 250 Newton meters at 1,500 RPMs. Then we go to the fourth step, where we will compute all the different maps. You can then visualize the table created. So this one is for the torque. We also have the fuel consumption map. And finally, final step is to generate those maps. So I will click on the generated selected tables, create some folder for this engine, call it new engine. Once the tables are correctly generated, you will see that the parameter settings are already done within this submodel.